Now, the reason why we have to have firewalls, configured is the following. And I quickly let me quickly see if I can discard. Let me quickly see if I can open whiteboard. Just bear with me. I will show you that. Ah, so you don't recognize me on my phone, on my device. Sorry for that. It actually should recognize me here, but yeah. Because I use that without any logins. It's anyway controlled already by the company, so don't know why I'm asked this. Okay. There's a test whiteboard there. I just want to use a normal whiteboard. Okay, so what is the issue using? Imagine we have the network where the 3CX is sitting on here now. Yeah, that can be local or hosted. Doesn't matter in the end. It's the 3CX is setting here. Now, what we have is we have somewhere in the cloud as well. We have the provider, yeah, the VoIP provider. And the 3CX registers to the provider. The 3CX we have somewhere here also, of course, I have to line that out very, very closely and very big. We have a firewall, huh? Something like that, yeah, that's the firewall. So now, the 3CX registers the trunk. It's not the provider who registers the trunk, it's the 3CX. So what we do, we're actually making an outbound connection to the provider. In that moment, since we come from the local network, wherever that is that hosted or on-premise, but the 3CX behind the firewall is in a so-called local network, which again is that famous RFC 1918 definition. It's a local network here. So the 3CX goes from local through the firewall out to the provider. We do that on a daily basis with our computers. For example, at the very moment that presentation that we have, I go out from our end to go to meeting and present my training there. You go out from your end through the firewall to go to meeting and you watch that training there. Yeah. The same way we do here with 3CX, we go from local through the firewall to the provider. In that moment when I go out here, the firewall opens the port. I register, the response comes back. Oops. I didn't want to have such a line. Anyway, the response comes back. It's registered. The trunk is registered now. Now, what happens is that trunk is now up and registered. You make a call to someone out here on his mobile phone or where else ever. So the call, let me see if I can change. You make a call, you go out here, and you dial that number. That person is not responding, but has a missed call on its phone. 10 minutes later, the person becomes available and does nothing else than dial that number back. You have to take this one here. Goes back, comes in here. Boom. Closed. Port is closed. Firewall is doing its job. It's a unrequested connection request. Comes from external to the phone system on port 5060 or whatever port you have chosen to be the SIP port, comes through there. It's closed. Firewall did the job. Firewalls usually, when you send out a request, they usually keep the port open for roughly 2 minutes. Yeah, depending. But then they close the port again. And you have to see that in that case, when you want to receive phone calls to a phone system, you really have to enable the firewall to allow incoming traffic. On a IT basis, you would create a VPN. You would not have the port open, yeah, in order to access something from remote, from external or what else ever. But the problem is with the voice, we have to be available to everyone. We can't just say, oh yeah, we give that person a dedicated port to call to or a VPN connection, that person, that person, that person. Now imagine if you have companies that have hundreds of calls every day, if they would have to give all their callers whatever kind VPN setup, or it's impossible. Yeah. The next point is that it's also a basic requirement from SIP that you have the endpoint or the source point is equal endpoint, or at least the source point here equals endpoint here. Yeah. So what I can use, for example, here I could go to 5070 as a source port. I have to have here 5070 open, but I can still register here on 5060 because the registration goes back then to 5070. Yeah. But that has to be equal. And that's what usually is changed when there is no port preservation done. Yeah, when there's no port preservation done, so no port forwarding, I come here, for example, with 5060, come out here with 5060, and the firewall lifts it then to, let's say, 21,220. Yeah. And then the call comes, or the information comes back, and then it gets traversed to something else. It is SIP traffic has to be guided. It's not like data traffic. It's completely different. So therefore, we have to prepare those ports. Now, I get the point that we have the issue on the firewall that we have 5060 publicly open. Everyone can try to get in, and that's the case. 5060 is prone to vicious hacking attempts. Yeah. So you have systems there, they get hammered and flooded with hacking attempts. That's actually nearly coming down to a distributed denial of service attack in some ways. Yeah. So in that regard, it is the case to here say, when you have 50/60, to 3.6 gives you a very, very beautiful opportunity to say or avoid the usage of. But I want to use stun because I have stun phones. Stun is actually also not supported really anymore on 3.6. And we have the tunnel. We have 5090. Yeah, the tunnel port, encrypted, can be used for the soft client, can be used for the mobile client, can be used for SBC and SBC phones. I already mentioned that chapter in the basic training, yeah? We have roughly, was it 15 phones or something like that from Yearlings, NOM, and Fanville that can be configured as SBC phones. So there's no need really anymore to use stun devices. Gives you the right and the opportunity to lock down 50/60, but you still have to fully open 50/60, as well as the RTP ports. Yeah, RTP port range 9,000 to 10,999. Yeah, because there's the same traffic, audio traffic, one-way audio, for example, comes down either to wrong public IP sent or to no port forwarding established. Yeah. Okay. Just that at the very beginning, since that slide already had the lined out the necessity of voice calls need to pass through the firewall to reach your PBX. Yeah. Under normal circumstances, again, the job of the firewall is to block external, unrequested external traffic to come in. And it's not so that you open the port on the firewall and say, this person can now call in because we opened the port. People call whenever they want. Yeah. Voice calls, they use several ports, SIP for signaling and RTP for audio. And again, firewalls block the traffic by default. We have to configure the firewall router to forward the calls to the PBX. The correct configuration of the firewall reduces the risk of network breaches. Again, use a different port, for example, instead of 50/60, use something else. It is the request, the registration request that goes out from the phone system to the provider that defines where the provider sends the request back to. So for example, again, let me quickly turn on here the pen again. For example, if I have the provider here, listens of providers mainly will listen on 50/60. I have the firewall here, and I have the PBX here. That's not only 3CX relevant. It's a basic SIP setup, yeah? PBX comes, for example, with 50/60. Firewall is not configured. The request goes out to 50/60. The firewall changes the port on the WAN side to 17,001, for example. The provider will send the request to that port, so the registration response to that port. But the port came out from 5060. Registration might happen, but does not have to happen. If then a call comes in to literally that PBX, since there is no opening here, the firewall receives the call on that port, but there is no connection open or what else ever. There's no request from active session going on that uses that port. The call will get dropped. Yeah. Now we can say we use, for example, 15,060 as the SIP port. Then we make a port forwarding on 15,060 over here to 5060 and have this one fully open. So we create a full Cone NAT where everyone can actually go through that port. That might work because all these SIP hacking tools at the moment, they only penetrate 5060, but it can be that certain SIP providers, they expect a request coming from 5060, or that we face also then in the future SIP requests, SIP stray requests, and all that stuff on those ports. General like port scanning. Yeah, we don't know what the future will bring. Therefore, the best way is use 5060 here, create here a 5060 rule where you lock down 5060 to the IP of provider, can be a whole range, doesn't matter. You have to ask your provider, and then we have everything working smooth and flawless. The firewall, then we use the web client, which uses the HTTPS port, or we use the dedicated port, which I had now in my on-prem install, or we use the mobile client, we use the soft client, they use 5090, or we use SBC phones or SBC on bare metal machines. Yeah, it's just publicly opening 5060 is risky. Absolutely agree with that. But the fact is that we have to ensure the system is working and the system is secure. Okay, good. For this module, you require a fundamental knowledge on routing. You have to have either for your customer a configurable firewall available, software-based, hardware-based, and you have to have good knowledge of the firewall device. 3.6 will not configure your firewall, so will neither Leader or Breeze Connect. Now, NAT and ports. NAT translates public IPv4 addresses to private IP addresses. NAT is network address translation, PAT is port address translation. It allows access or restricts it. We can have ACLs in place. It is required to allow connections to 3.6 from providers, 3.6 apps, SBCs, and bridges. IPv6 is supported. Masquerading via NAT is not supported. Firewall rules are required if that is used. PBX requires full Cone NAT. You require full Cone NAT only for the firewall tester, else not really. Allows incoming traffic from uncontacted sources required for VoIP provider, multiple IPs, mobile devices, routed IPs, home offices, dynamic IPs. Now, VoIP provider, that is the trunk. using 50, 60 or what else ever. Mobile devices. Mobile devices can call in via the trunk. So for example, if I call a 36 from my mobile number, I go via the trunk to that PBX. If it is my Leader 36 mobile app, then I connect to the 3CX directly using 5090. Home offices, dynamic IPs, first rate, that is an old list. In that regard, dynamic IP stun goes 5060. Oops. 50. Oops. 5060. Stun is not a discussion anymore. Therefore, 5060 is dead there. Home offices, dynamic IPs. When we use the soft client, we use 5090. If we use the web client, we use HTTPS port. We actually have the session running there on the actual web server on the 3CX HTTPS port, so which is in the end either 443 or in our case now is 5001 or whatever. And then we have desk phones, so DP, use an SBC phone, 5090. Okay, so there's only the trunks who require 5060 when we do a proper setup. So therefore, we don't really need a full Cone NAT because this one, we again lock down IP range of provider. Huh? So you see 56 is generally only needed for the trunk. If we do it properly, everything else we can solve with thing. Full Cone NAT, we do that at the very beginning when we use the firewall tester, which we see then afterwards. Else we do not want to have 5060 open. Port preservation or port forwarding, the internal source port equals the external source port. I showed you that already before in one of those scribbles. It is in SIP, it is the protocol that defines the port and not the transport header. That's unique to VoIP. So therefore, there's a different way of thinking that needs to be applied on when you come from IT, from networking to SIP. Yeah, it's just a definition on the protocol. Yeah, it's a SIP standard definition, and it is not a 3CX whatever kind of definition that defines that we have to do it that way. It ensures connectivity and it eliminates destination implementations. We see here, we have a PBX, that would be the PBX, uses 5060. We have here the firewall on the local end with that IP address. On the remote end, we would use again 5060, and then over here we would have the called destination, which we probably could be a web client or what else ever, which uses 443. SIP ALG, SIP application layer gateway. Inspects the content of the package, tampers uncontrollably with content. It is made for clients, not servers. So who attended the basic training from the very beginning, you will also see that then on the introduction video that I extra added or left up there once the different sections are uploaded. I have to follow that up, by the way. Don't know when that stuff is going to be uploaded finally. It hasn't been done yet. But I said when we talk about the hardware that is used, use Pro devices because we are working in a business environment. Do not use do-it-yourself devices. Yeah. So usually what the customer becomes from his ISP is a device that is very, very low level because it's cheap. And usually these devices have at the back of the device two RJ11 ports for analog phones. These are customer client devices, and they often have either statically 5060 assigned to these two ports, so you can't even use 5060, or you have to reconfigure that device. However, ALG, SIP ALG is done for these solutions where you have an end user who is literally the extension to a higher placed phone system or to their providers, internet service providers' phone system. For example, Telstra is one of these companies to have those phones working properly. Yeah. That's correct. That's fine on these devices because also clients need to have those devices, but it is not wanted in a business deployment because what we have here is not, we have not an end client here, we have a PBX on our end. And we are not an extension, in a way we are an extension, but we are a phone system. The setup, how it is outside there in the PSTN is we have phone systems, phone systems, phone systems, phone systems, phone systems, and then at some point we have a phone system that has users behind them. Yeah. And one of these phone systems here is our 3CX. That's, for example, this one here. And this connects to another PBX. Yeah. It's a higher elevated one. And we have then here, we have the extensions. Yeah. And we connect that here to that here, not this here to this here. That's not what we are wanting to do. Yeah. And in that moment here, it can be helpful to use SIP ALG, but generally not. That's just for end users here with plug in analog phones into the back port of those. But we communicate with another PBX. So therefore, we do not want that. Yeah. So what does SIP ALG do? I send out information from my phone system across to the destination. That can be the SIP registration to the provider, or that can also be a normal call to someone else. Now, if SIP ALG is enabled on the firewall, it will change the information that is sent. You see, we have here very basic 1, 2, 3, 4. It changes it into 2, 1, 4, 3. Yeah, it adds and changes the content of the SIP package, and the remote end says, "What do you mean with that? I can't read that. That's garbage." Yeah, drops it. Okay. So, and SIP ALG is literally setting on every hardware, on every firewall. You have to make sure that it's disabled. Now, set up for providers if you want to connect to the provider using a SIP trunk. SIP port can only be changed during the installation. By default, it's 5060 UDP TCP. We can change that port to any port you want as long as you do the whole setup properly. So which means on the phone system, we would then have, for example, as I said already, 15,060. Then we would have to do a NAT on the firewall using 15,060 pointing to IP of PBX. Yeah. So it's in this one. The audio ports, this includes video and fax, so also the web client and all that stuff, is by default 9,000 to 10,999. UDP only. For SMS, we use the HTTPS port, by default 5001. I am not so sure about that one because you saw before I had to change it to 5001. By default, I'm 100% sure it would be 443 by now. I'm not sure if that slide needs to be changed. When we have these 3 port ranges, so the 50, 60, which is the standard SIP port, the 9,000 to 10,999, and the HTTPS port, I stick now with 5001. If we have them enabled on the firewall here, we have prepared more than 50% of our port forwarding. You will see in the next slide, nearly everything will be a replication of these ports. Yeah. Setup for 3CX apps, SBC, and bridges. So the 3CX apps is the mobile app. It is the soft client. The web client is not in that regard because the web client doesn't use the tunnel. So that would be mobile app, mobile, soft client, then SBC as a barebone and SBC phone, and then bridges. Yeah. Inbound NAT required for by default 5090. Also here, I can change that. I have to do the setup properly. UDP, TCP, and presence is the word I was searching for the other before, much prior. 51, yeah, so 5001 by default. HTTPS, again, I am pretty sure that's meanwhile 443. I have to check that. I have not received newer slides, so from that perspective, yeah. Now, 3.6 web meeting. Inbound NAT port required HTTPS 5001. So if we go back, HTTPS is already here. Yeah, we use HTTPS here. So you see, it's one of those that I said is a part of that. We added here, new to the ones that we have here, we added 5090 to that. So we have 5060, 9,000 to 10,900. And HTTPS, I leave that now by 5,000. These are the ones from the first side. Now on on this slide, I add to it 5090. And I can tell you now, with that, we have all the ports forwarded that we need for the whole setup. Everything else from now on will be replication, except we are looking then into secure SIP. There are then additional ports to be added. Now, if we host a web meeting on 3CX, the following will happen. This one is a local participant. You do not see that correctly, but if we put the border here, then that is a local one. The other ones you see, they go through the firewall. So the 3CX is here on-prem. This one is local, and the participants, the remote ones, are external, of course. Now, they connect to the PBX using 5001 or HTTPS port, whatever port there is used, to get the info, the meeting info. And once they have the meeting info, they literally go out there. According to 3CX, the MCU cluster information will become less complicated in terms of changing IP addresses. We come to that then on the next slide. But that's just for you to see. We require for the meeting information so that the participants get the meeting information from the server. They use 5001, so HTTPS via the browser, but the meeting actually happens outside of 3CX. Now, for the web meeting, we have to allow outbound traffic to the WMR server, which is wmr.3cx.net. So that domain has to be allowed. The MCU servers, they create the meeting and get the recording, etc. There are multiple servers per region, and the IPs change regularly. The IPs change regularly because the servers become available based on the demand. So if there is no high demand, there will be not so many servers that are available. If there is all of a sudden a peak in demand, automatically more servers will become active. And since these servers differ, there will be a different IP address for them around. Now, the web client in SIP mode or the progressive web app, we use 5001 and the audio range of 10,500 to 10,999. Now, you remember the RTP range is 9,000 to 10,999, which that is included in that range, yeah? So remember, we had 5060, that audio range, 5000 and 5090 on the second slide. And from here on, it's all just a replication on the port forwarding. So once you have these ports and these ports forwarded, you have all ports forwarded. However, for providers, you require these ports. For apps and bridges, you require these ports. For web meeting, you require 5001. For the web client, you require these ports. These were always common questions in regards of web client only needs, or web client needs port 5001 and 9,000 to 10,999, or audio port range 10,500 to 10,999 UDP TCP, where TCP is wrong. You don't need TCP, where for audio is only UDP, yeah? HTTPS is only TCP. This used to be questions. Again, I have not done the exams yet, so I don't know the questions that pop up in that regard, yeah? If we do Teams integration, we require the secure SIP port 5062 for TCP. If the Teams SBC FQDN domain is the same as the 3CX FQDN domain, 5061 is used. For the audio, again, we use 9,000 to 10,999. The remote configuration wizard, that's the 5015 port, HTTP. You remember when we did the on-site or the on-premise setup before, when I went to the IP address and then did the 5015. That is only during the installation of the host. Yeah, and I would not use that as a port forwarding on the firewall. I would probably have if it's on-site, on-prem, I would have a different device on-site where I actually remote into that device here. So literally go via RDP to another device and then go onto that. If it's hosted, yes, if it's hosted, you literally have to do that port forwarding on hosted. Definitely this one is required. And afterwards, when the system is set up, close that again. Okay. Firewall checker validation. We see that in the dashboard. We see that afterwards. That video afterwards doesn't take that long. Green is pass, red is fail, even one red is fail. Reconfigure the firewall. The firewall checker only tests UDP ports, no HTTP, no SIP or tunnel TCP ports. Yeah. So SIP UDP is tested, tunnel UDP is tested, but no TCP for SIP or tunnel. So you start, and then here you see it failed. Full contest failed. Most likely it failed because the firewall is locked down, which is achievable, but you do that after you did the test because you do the test to get a green tick, yeah? And then here again, 5090, full contest failed and all that stuff. Either it's no port preservation at all implemented, or there is no the full cone available. Firewall configuration has not been done or is incorrect. Contact firewall manufacturer support if needed. Do not call 3CX support for assistance configuring your firewall. Do not attempt to create SIP trunks, bridges, or remote extensions. Remote extensions or SIP trunks won't register. Now we go further. We see SIP ALG is not detected. The 5060 has been full cone is available, 5090 full cone is available, but the media is not done properly. So review and fix your firewall configuration. Contact the firewall manufacturer support if needed. Do not call 3CX support for assistance configuring your firewall. Do not attempt to create SIP trunks, bridges, or remote extensions. In this example, remote extensions will register but will have no audio. And then here you see literally done, success, blah, 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 blah. Yeah. Full Cone NAT has been correctly configured and tested. Port preservation has been correctly configured and tested. SIP ALG is disabled and tested by the firewall checker. TCP ports cannot be tested from within the PBX. Not detected. ALG was not detected. Detected. You see, checksum sent is unequal checksum received. SIP ALG was detected, must be disabled on firewall. Failed, test was not completed, PBX was not able to communicate with the SIP ALG detector, response was not received from SIP ALG detector, just retry again. Now, one moment, any questions? We look at the video quickly. Now, what happened on my end, because I have a flat network, and that is then the thing what happens in the future with people who don't have DNS servers on site. You remember you require now for the DNS server, you require an FQDN. So you need a local FQDN as well now at the moment. So what happens now is literally the setup that I have. I have a firewall here. I have my 3CX here. I have an IP phone here and another IP phone here. and I have Google here. So now that phone registers on FQDN, goes that way. Hairpin NAT. That phone registers on FQDN. Yeah. So the firewall resolves the FQDN from the 3CX to the public IP, of the 3CX. So literally, what happens? The phone tries to reach the phone system using the FQDN, not the local IP address anymore, using the FQDN, so which means it sends a request to the gateway. The gateway knows, oh yeah, that FQDN is that public IP address, and sends it via Google, sends it back through to the port that is open here, forwarded to the phone system, and it registers. Okay, so let's quickly have and of course, when your customer has a DNS server on site, he can manage that properly. So let's quickly look into the firewall configuration. So, okay, that is the system that we just set up before. That was just literally cut off from the system when the former movie ended. I did a cut there, and you can see down here the firewall is red. Where do we have the firewall? I was searching the firewall. We go in there, press start to run the firewall checker. You see, SIP ALG is not detected because I have that disabled on that router there. /5060 port forwarding is also done. /5090 full cone test failed. Full cone test on /5090 failed because I have not added the rule there. I didn't check if the rule is there. Audio ports, they all are fine, but /5090 is not good at all. So that run through, it said last firewall check failed, run the check again. Of course, I have to go into that that's really a basic Wi-Fi router that I have there. Go into NAT forwarding. You see there, SIP ALG is disabled, and I have an old rule in there, which I had for something else enabled. And now I add quickly a /5090 rule. The thing here is with that basic thing, with that basic device, you see you can't lock down ports to remote IPs. So from that perspective, I would not advise to use such a device. Now we have that running again. It's actually already a surprise that this device is able to do port forwarding. It's such a basic device, but again, it's doing its job for that example here. You see now 5090 is green. That has been done successfully. Dashboard, and we see the firewall is green. That's what I usually say then. Okay, you do that. Just bear with me. Go back a second. The firewall is green now. So that's what I do, just that to get that green tick. You have everything open. Make that firewall check. Firewall becomes green, and then you lock it down. You lock down port 5060 to the IPs of the VoIP provider. So that is all enabled now. What I do now is I disabled HTTPS on that device so that literally port forwarding is not working anymore. And now it's exactly what I told you before. You look at the top, I have FQDN in there. I closed the port 5001, so the HTTPS port where I connect literally to the management or to the console or to the web client. And I'm in the same network, in the same local network as the phone system. But since I need to use hairpin NAT, so which means also with the browser here, I go out into the internet and come back in via port 5001. I am not able to reach the 3CX now because I have closed port 5001. Yeah. Again, if your customer has a DNS server on site, you can configure that properly. Yeah. But if your customer, and this will be a lot of customers who don't have DNS servers on site, you have to use that. Yeah. And you see, I just opened that port again, enabled that port forwarding, and I can come back to the web GUI.